years ago, actually on April 12, 1961, Soviet cosmonaut Yuri Gagarin became the first human to travel into space and orbit the Earth. Gagarin's trip took 1 hour, 29 minutes, reached a height of 187 miles, and at that time was the first human venture off the Earth. Since then, the best I can tell from a little research on the internet is that there have been about 550 people who have followed him into space. 12 of them have landed on the moon, and 18 of them have lost their life in the pursuit of spaceflight. In light of this amazing human achievement, we thought it would be a good idea to recognize this 50th anniversary of human spaceflight by inviting Villanova's own astronaut, Andy Allen, to be the distinguished speaker at this year's Patrick J. Cunningham and Susan Ward Endowed Lecture Series in Engineering. Mr. Allen is currently the CEO of Aerodyne Industries, a service-disabled, veteran-owned small business that is a top engineering and IT solutions company. Previously, from 2004 to 2007, Mr. Allen held executive assignments with Honeywell, serving as Vice President of Space Programs and Requirement, Vice President of International Military Aircraft Programs, Vice President of Space Systems, Sales and Marketing, and Vice President Program Manager for Engineering Services to NASA. Prior to joining Honeywell, Mr. Allen worked from 1998 to 2004 for the United Space Alliance, the prime contractor for NASA operations and maintenance of the Space Shuttle fleet, astronaut training, and mission control. His most recent position there was as program manager for ground operations, and as such, he was responsible for managing and leading more than 4,000 employees and performing Space Shuttle processing, launch, and landing operations at the Kennedy Space Center in Florida. Before joining United Space Alliance, Mr. Allen served as a NASA astronaut. Selected by NASA in June 1987, he is a 3-time space flight veteran and Space Shuttle commander with over 900 hours in space. During his 10 years with NASA, Mr. Allen also served in a number of technical and management assignments, culminating in his final assignment as Director of International Space Station. While here, he was a member of the Navy ROTC unit, received his commission in the United States Marine Corps in 1977. He was a Marine aviator. He flew F-4 and F-18 aircraft, and before retiring from the Marine Corps, he logged over 6,000 flight hours in more than 30 different aircraft. He holds a number of distinguished honors, including the Defense Superior Service Medal, Legion of Merit, Distinguished Flying Cross, Defense Meritorious Service Medal, Single Mission Air Medal, NASA Outstanding Leadership Medal, NASA Exceptional Service Medal, and NASA Space Flight Medal. He's a member of the Society of Experimental Test Pilots, Association of Space Explorers, and serves on the advisory board for the University of Florida Business School. He holds a BS in Mechanical Engineering from here and an MBA from the University of Florida, and 3 honorary degrees in Public Service, Engineering Science, and Management. Today, Mr. Allen will talk to us about technological packing for a trip to space. Please join me in welcoming Mr. Allen.
Okay, well, thank you all very much. Can everybody hear me okay out there in the back? All right, good. I usually walk around a little bit while I'm talking, so if I get too much of a moving target, let me know. Listening to my resume, to me it kind of struck me as somebody who's got attention deficit because I seem to move around a lot and do a lot of different things. And maybe that's true, but it kind of shows that what I really wanted to do and what I did was just keep on trying and just keep on learning. And as soon as that learning curve kind of got flat a little bit, I thought of something else to do. So when I was done flying airplanes and rockets, I decided to try myself into the world of business, get an MBA, try to learn about that a little bit and go into that business world. And I would tell you that when I wore a flight suit to work every day, it was a lot less stress than running my own business and being a business guy. It seemed like life was a lot simpler back then. I worried about killing myself in an airplane, but that was easy compared to some of the stuff you got to worry about in today's economy. So what I want to do is just talk a little bit today as I look out there in this audience of folks that, you know, you come back to your alma mater and it's changed a lot since I was here, but there's a lot of stuff that hasn't changed. I still see people in shorts and flip-flops in the middle of what I think is winter around this campus. We came up here from Florida yesterday, where I live now, so we went from tornado warnings and thunderstorms to we got snow last night. So it's a little bit of a change in coming up here, but it's always great to come back, and it's just a neat place to be around people learning. And the other thing I was impressed with, I got to spend some time this morning looking at some of the labs and walking around with Dr. Jones. And the level that you all are at and where you're learning things and where your baseline is coming out of college is about the baseline that I was at when I was 20 years out of college. And even still, it's probably superior to the baseline that I'm at today on kind of the things that you're looking at, the things that you know, things you're studying, and just how much talent you have and being able to move this. So it kind of really fits in nicely with the fact that I want to talk about technology a little bit, because it drives us and because it makes us the great civilization or the great economic power that we really are. So I'm going to start out a little bit with some of that, and then I'm going to go into some of my space flights a little bit and give you some more of the esoteric and entertaining parts of what it's like to be up in space. So if you'll bear with me for a little bit, just to kind of give you an outline of the way I think sometimes is, this is my You Are Here slide. So this is a little bit of a picture of the Milky Way galaxy, and to try to put some things in perspective, we're this little sun, our sun is this little star inside the Milky Way galaxy. And if you could put our solar system on a quarter, if you looked at the solar system that we have about the size of a quarter, the sun and the earth would be little specks of dust on that quarter, and our galaxy would be about the size of the United States. So it's a big place. We've got a couple 100 billion stars in our galaxy, probably, even though the scientists don't really know exactly what yet or how many. And we're about 100,000 light years in diameter of our galaxy. Well, light years about 6 trillion miles. Speed of light's about 670 miles an hour, 186,000 feet per second, so it's pretty quick. And if you think about our own exploration, our own history, it's probably not that far off from some of the people that were well back into the 15th and 16th century that were trying to transit this place called the Atlantic Ocean and find this new world out there that later on would become the United States of America, North America, and South America. So there's a lot of exploration that's involved in all of that, and the vastness of trying to understand the technologies that had to happen. So we land on Plymouth Rock, and from Plymouth Rock we have Jamestown colonies, and we try to expand our way out. We had to develop a lot of technologies. When you have a mission in mind, you create a lot of technologies to support your mission. If your mission is to try to get to the other side of this country and get to the Pacific Ocean, you may not know that at the time, but you're going to develop a lot of technologies in communication and logistics and transportation and medicine. All that stuff comes along. We can't imagine the technologies of what you have today that you're all spoiled with, most of you that are on the younger side, that we couldn't even fathom when I was sitting, not in this room, but when I was sitting here in some room around campus. I mean, who would ever thought that we could talk on a phone that wasn't connected by a wire in the house? Whoever thought that you could watch TV that wasn't connected by a wire with an antenna on your house? Who would ever thought that we'd have these little computers attached to our belts or carried around in our purses that had so much computing power, it boggles the mind. More than all the space shuttles put together is in my iPhone as far as computing power. So there's a lot that's there. And the capabilities we never fathomed. Who would have ever guessed that a 7-year-old could run a computer better than I could do it at 40 years old? I mean, but it was a computer back when I was 7 years old. So the technology is never going to stop. The technology is never going to change, and there's a lot out there. So we take this little place that we have, in this little galaxy that we have. So in about 600 years' time, we went from Columbus to pretty much the final state of the United States of America, and a lot happened in that time frame to get there. So that's why I kind of say that we're on the very front end of discovery of what space exploration is all about. And what space exploration does is it drives technology development. So we do space exploration for a lot of reasons. Sometimes it's scientific discovery, sometimes it's national security. And sometimes, and oftentimes, and most times, there's some economic development and benefit that goes along with space exploration. So here we are, we're just kind of starting out. We're really in a primitive state when you think about space. And a lot of the things that we had to do to get past where we're going to go here is develop some new technologies that go along the way. A good example for me is sometimes the difference between fact and fiction is just time. I had a grandmother who I guess was born at the end of the 19th century, really, and she never learned how to drive a car. She never thought that anybody should ever be in an airplane because it wasn't normal. So she grew up in the early 1900s when all this stuff was being developed and being invented. And when I called her up and said, Grandma, you know, I got accepted into the astronaut program, and her response was more like, so are you moving to Hollywood, California? I said, no, I'm going to Houston, Texas. And she says, well, we never really landed on the moon. I said, no, Grandma, I really think we did. So she never believed that we were meant to do the things that we have done in her lifetime. So in her lifetime, she saw a tremendous amount of things that you would have never fathomed could ever be seen and discovered and invented in that timeline. And of course, once she passed away before my first flight, so she had a better seat for my first flight anyhow, and she knew that we really did go land on the moon, and she knows a lot more about space travel than I ever will once she passed away from this place. So we worry about a lot of stuff sometimes, and about exploration, about technology development. So let me put a couple things in perspective, because it's really important to understand perspectives of things. So in our country, we spend about $3.5 trillion or more a year in our budgets that we get out of Congress. And my numbers are plus or minus a little bit, by the way, because they might be a little bit old based on 2010 numbers. And the 2011 budget hasn't even been passed yet, so we're still playing around with that one in the halls of Washington, D.C. But every day, we probably spend about $2 billion a day on Social Security. We spend another couple $1 billion if you add in Medicare and Medicaid. You add in a few more of the other mandatory spending programs that Congress has to deal with and pass those kinds of budgets. We're up to $6 to $8 billion a day we spend on entitlements and subsidies and programs that are out there. So that's about 64% of our tax dollars we spend on entitlements and subsidies of helping people out for one reason or another. So that leads you to the rest of the pie that's out there called discretionary spending. And out of that, the Pentagon probably spends about $2 billion a day in the Pentagon. So it's about 24 cents or so on our tax dollars. Well, the NASA budget on our tax dollar is about half a penny. And to go to the moon and Mars, like we had wanted to do on the NASA plan, that would have taken another tenth of a penny. So we're about up to 6/10 of a penny if we wanted to go to the moon and Mars on NASA. The administration wants to keep it at the half a penny level, so we're working to see how we can figure out how to do all of that. So it's not very much money. The Space Shuttle operating budget, Space Shuttle is going to get retired this year. It doesn't have to be retired for technical reasons. It's really political reasons it'll get retired. We spend more money on lip balm in this country than we do on the Space Shuttle budget. We spend more money on Coca-Cola in this country than we do on the whole NASA budget all put together. So I just like to put things in perspective, because what I am trying to say, when you have an issue of subsidies that we have, which I won't say is a bad idea, and I won't say that a politician isn't smart enough to figure out it's political suicide to go attack some of those entitlements and some of those subsidies, what you have to have on the other end to make it all work and to make sure we don't become a third world country one day is you have to have economic clout. You really have to go out there and create new economic opportunities for us to be a rich nation. And that's what technology does. And that's what you as engineers, for those of you that are engineers out there, that's the kind of stuff that you do. So when the scientists come along and they discover something or invent something, It really takes the innovators to figure out what to do with what that discovery might be, and it takes the innovators and the engineers to put it together and create something out of it. We were out there studying the electromagnetic fields and radiation and the spectrum of space travel and looking at gamma rays and X-rays and IR and visible light, and nobody ever figured out that you could take those studies they did out in space, and somebody finally figured out that you could create microwaves and popcorn in microwaves, and you could create laser IDs to help you get through the grocery. That's not what the scientists were thinking of when they were discovering this and the first innovators and inventors, but that's what we got to get at. MRIs and CAT scans in the hospitals. Those are kinds of things that really came out of space technology, things that are driven by space technology. So those technologies have an everyday impact on life. Communications is probably one of the biggest things that took us to the moon. Computer development took us to the moon, and the medical stuff, and I'll talk about that. So here we are, and we're at this very beginning state. So if you can go back in time, we're someplace 500 or 600 years ago when we're just getting over here, figuring out that there's something out there that later turns out to be the country that we know of today. So we're not much different than those folks that were a few hundred years ago trying to figure out how to get from here to there. Our nearest sun is about 400 light years away. So at today's travel, it would take you about 70,000 years to get to it. Out of that galaxy that we have of a few 100 billion stars, we think there's a few 100 billion galaxies that are out there. So there's more stars in this universe than there are individual grains of sand on Earth. Scientists think, I'm not a we, so the scientists think that there's probably about 2 billion planets like Earth in our galaxy. Whether there's intelligent life in those planets or not, I don't know. I guess we'll find out. I mean, there's a couple different schools of thought. One school of thought is if there's intelligent life out there, we'd know about it by now because we've been studying it. We've been talking to it. I know a couple astronauts that try to telepathically connect to somebody out there and say, hey, come pick me and let's talk. And nothing's ever happened. We haven't seen any radio waves or TV waves or reruns of Family Feud or anything out there. And we've been studying things that are within a couple hundred light years of our planet, and we haven't found anything. So the one theory is there's not intelligent life out there. There's another theory that says that there is intelligent life out there, that proof of their intelligence is that they're not contacting us. So we don't know is the bottom line, and one day we're going to find out. Statistically speaking, is there life out there? Absolutely. And we'll figure it out one day. Earth is going to die one of these days. It's going to die because the sun's going to die and take Earth with it. Or we're going to have another mass extinction. We had a mass extinction back in the dinosaur days, about 65 million years ago. A lot of people have different reasons for what that cause was. Some think it was a big asteroid that hit. Whatever it was a mass extinction. And that's not the only mass extinction that the Earth has ever had. It's had a few others before that, which is why we've gone through different tables in our history of Jurassic period, Triassic period. There's been mass extinctions all along the development of this planet that's been around for a couple 100 million years. So it'd be nice to know that we have a place to go. Pack everybody up, get them in the van, get them on a rocket, and go to some other planet somewhere that we figured out how to make into a new planet. So we're just beginning. This space shuttle stuff of going around the world and going to the moon, that's easy stuff compared to what we have to go forward. So we start out by creating technologies, and we get it to the explorers so the explorers can go out there and find the things and develop the things that we all want to learn about and get there. So explorers have been around since the beginning of time. They will always be around. Great civilizations have come and have gone based upon their technologies that they have or don't have. When they have the technologies, it's great. When they don't have the technologies, it's not so great. You'll recognize some of these scenes that I've plagiarized as I put this thing together. That's me when I had dark hair. And a lot of the stuff that happens in our fantasy world will become real. There's only a few laws of physics you can't go against. But if you can work with it, then you can go out there and you can find it and you can explore it. And then the scientists and the engineers will develop the ways to get you to where you need to go and to bring you home, or to let you stay there and live. Transportation faster than the speed of light, that's a tough one. We might get there, we might not get there. Human transportation, it'd be great to commute from Tampa to Philadelphia every morning and only take about 3 seconds to get here. I mean, that'd be a fun thing to do, but I don't know if that'll ever happen or not. But this kind of stuff that's been out there will, because if you think about people like my grandmother, it all happened in her lifetime, things she couldn't even fathom as far as technology development. So it's out there. We're going to go explore it, or somebody's going to go explore it. My brother would tell you this is a baby picture of me, but it's not. This person is named Ham. This is my pick on scientist slide, because what I do with this slide is I basically say, you know, scientists are great. They study a lot. They're smart people. And what they'll do is they'll have an opinion. Sometimes they actually will discover something, even though a lot of times what scientists will discover is completely useless until somebody figures out what to do with it. So discovering lasers was relatively useless until somebody figured out, well, here's what I can do with laser light. Here's what I can do with microwaves. Here's what I can do with X-rays. Here's what I can do with magnetic resonance. So those are the kinds of things scientists can discover it, but somebody's got to figure out how to do it. So those innovators and those engineers package it and figure out what to do with something. So sometimes it starts out pretty useless, but they have opinions. So back in the early days of space flight, and as we were exploring space, there was a lot of scientists that said, hey, listen, when you get into space, you're going to die. You can't survive in space. It's not going to happen. Your body's going to change too much. You will not be able to swallow. You're going to die. You're going to suffocate. So smart engineers said, okay, well, we won't send a person because that's bad press, so we'll send monkeys. And that's what we did. So we sent monkeys. The Russians sent dogs. We sent monkeys. And this is Ham, which was the first chimp to orbit the Earth. So you can also see there's not a whole lot of difference between astronauts and chimpanzees. We all go up in space. We all get incentivized one way or another to perform behaviors, and we go up there and do that. But there was other scientists that said, no, I think it'll work just fine. I think the body will adapt and the body will function. The body will be just fine. And they were right. So that half was right. Same scientist, not the same scientist. Another group of scientists says, well, if you go land on the moon, you're just going to get sucked in. It's like quicksand. Others said, no, it's not. So the scientists aren't always going to agree. Take global warming, a recent example. You can find scientists and they'll have different opinions about global warming. It's been there since the beginning of time, maybe. So let's go back to the space shuttle, which again is something that's on the very front end of exploration. So, you know, in relative terms, space shuttle is not a whole lot different than Christopher Columbus, or even somebody even before Christopher Columbus. So it's something early on in that need and that strive of what we got to go and what we got to find out and what's out there. So what is there to go do? This is Columbia, one of my Columbia trips. Kind of lonely when you get out there. You go out there and nobody else is around except the people that are going to strap you into the vehicle. You're excited about being there, but at the same time you know you can't change your mind or it'll look bad, and NASA will get mad at you if you change your mind and say you're not going to go. So you go. You go fly. And about 6 seconds before liftoff, those solids lift off. Or the rocket engines ignite, then the solids lift off at T0. You know, it's a great and wonderful opportunity to have, but we're just scratching the surface. So you get up there, and you actually probably will feel more insignificant than significant. There's only a few people that have gotten a chance to go up into space, and there's a lot to smile about when you're up in space, no question. But at the same time, when you look out the expanse of the stars, it really makes you feel pretty insignificant of who we are out there. And maybe we are the intelligent life that's out there, since we all might have started at about the same time. So just a little bit of synopsis of the space shuttle world. We have 2 decks. We have what we call a flight deck and a mid deck. Crews train for probably 2 years or so together before they go fly in space. You know, it's a relatively select group of people because the psychiatrist's got to take a shot at you before you get selected. All the parts of your body all function right, and that they don't have to worry about you too much when you're up in space, because it's too hard to get you to the hospital if you have something go wrong while you're up there. Great opportunity to look at some of the history and some of the geography of the Earth. So the number 1 commandment of a commander is not look bad on CNN. So you come back, and when you land, you just make sure that your wheel's on the center line because that'll be on camera. So I had 3 flights. I didn't talk about that earlier, but I was on Atlantis for 8 days. Then I flew Columbia for 14 days. Then I flew Columbia again for 17 days. And we'll talk a little bit more about the missions and the experiments of the missions when we get back. So most of what you see there at liftoff is steam. We put out a couple 100,000 gallons of water so we don't crumble the launch pad with the forces of the solid rocket booster. We got about 7 million pounds of thrust at liftoff. The vehicle weighs about 4.5 million pounds, so better than any ride at Disney World. It's a good kick in the pants when the solids light off, and there's no doubt in your mind a significant event has occurred in your life. You're not positive of where you're going to go, but you know you're going to go someplace. I would tell you that I don't think it really takes a lot of intelligence to get strapped into a rocket. If my mother was here, she'd tell you it was a lack of intelligence to get strapped into a rocket. The intelligence is what makes it work. So for every one astronaut, there's tens of thousands of people that make it all work right. There's millions of things that all have to come together just right to make this thing work. Any one thing can go wrong and ruin everybody's day. And when you're laying out there on the launch pad, you get strapped in about 3.5 hours before liftoff. When you're laying out there on the launch pad, a lot of stuff is going through your head. You know, a lot of it will be the kinds of things that if they go wrong, you know, on the human capability side of it, we're pretty well trained. And if we're right on top of an emergency, we're right on top of an action, we do the right diagnostics within a split second, we can survive an event. There's it's not a lot of time thinking about it, but there's the acknowledgement of the fact that there's a lot of things that can go wrong with the space shuttle system where we can't do anything about it. It's going to happen. There's nothing we can do about it being on the inside. So you get over it pretty quick and you say, well, you know, maybe they'll name a school after me or whatever, but there's no sense worrying about it now because I can't change a thing. So don't sweat the small stuff. If the solid's going to blow up, you know, I'm just not my day. So we're not really very busy for the 3.5 hours. We kind of get strapped in. We get time to think. You get time to take a nap. Some of the mission specialists like to talk a lot. The pilots and the commanders don't generally talk a lot because we're either trying to catch a quick little nap or we're just thinking about stuff, and we're trying to make sure we don't screw anything up. I mean, that's kind of the prayer of the guys in the front, the pilots and the commanders. You know, dear God, don't let me screw this up kind of a thing. Alan Shepard had different words for it, but it's the same basic prayer. You don't want to look bad. You don't want to make a mistake. You make a mistake and it can really create some significant issues. It's a pretty powerful ride. There's a feeling of power of what has to happen to make all of this work. So we go in this and we're riding and so many things are happening so fast. We go from about 0 to 100 by the time we clear the tower. We're doing 100 miles an hour. Within about 30 seconds, we're well supersonic. So we're traveling about 2,000 miles an hour or so in about 30 seconds. 8.5 minutes, we're traveling 17,500 miles an hour. So we're in an escape velocity out of Earth's atmosphere. And there's a lot of acceleration along the way. About 3 Gs, which isn't a whole lot except to sustain a long time. So it's kind of like there's a 600-pound gorilla sitting on your chest, and it gets a little hard to breathe, and you just kind of gut it out, especially that last minute or so. And then all of a sudden it shuts down and you're in space. And you're at 0 gravity. It's a little bit of a shaky ride at the beginning when the solids are working. And the engineers that put propellant systems together for the solids are pretty smart because if you have more than about 60,000 pounds of differential thrust, it'll tear the whole vehicle apart. So you got to burn the solid propellant just perfectly to make sure that we have a good ride and that it goes up. So again, like I said, it's a little shaky on the inside. You get a lot of the gouge before you go fly, so you're very busy. You're looking at displays, you're looking at instruments. It's like you're in the simulator. You're waiting for the simulator training team to throw some emergencies at you. But generally, nothing goes wrong, at least on the ascent. You're ready to take over manually and fly manually if you have to fly manually. And right at about 150,000 feet, if you're on your first flight, they'll tell you to run your seat up real fast and look out the window because that's about the point that the sky is going to go blue, blue, blue if you're on a day launch. and then it'll just be a line of black. It'll go perfectly black in a split second, so it's kind of cool to see it. Solid rocket boosters come off in about 2 minutes. They parachute back down to the ground. Ride becomes very smooth at that point, with the exception of the G-forces that you have on you. And 8.5 minutes later, you're in space. We fly, we're unisex, so we fly both genders up in space. It's a little bit more of a problem if you have long hair than short hair when you're up in space. So Marsh Ivins, who I actually flew twice with, likes to take the Medusa look when we get up in space. It's a little bit of a challenge when we're working, so we only let her hair out when she's taking pictures. Otherwise, she puts it in ponytails that kind of float out. It looks like Pippi Longstocking in the ponytails. We do a little bit of like advertising when we're up in space, so we get a chance to take a couple things up. Somewhere out there, I had a Villanova picture holding the Villanova pennant. Same thing, probably right before I held the Marine Corps pennant. This isn't really to show you anything that I'm super proud of or is worthy to be in a magazine, but this is kind of a slide to talk about a couple different things and some of the technological advances that really need to happen when we're up there. So we are what the doctors call a unique data set. Well, all that means is we're a group of people that they get to do a lot of experiments on and get away with it. And you can't do that on a regular basis down here on Earth. And you can't do it generally with healthy people down here on Earth because there's laws against all that stuff. So they have this group of people that are volunteers to go up there, and they will do medical experiments on us. Some of them are invasive, some are not so invasive. The commander gets to pick who gets what experiments, so don't ever get the commander ticked off at you. So the commander, my first 2 flights were as a pilot, and then I got to be the commander. So as the commander, I wanted to make sure I took all the easy stuff for my medical experiments. So this is one of my earlier flights. And about 85% of the astronauts get some kind of motion sickness when you get up into space. So one of the physiological functions and challenges that the doctors have to deal with is how do we help them? Because as soon as we get into space, the people that write up our schedules, we go to work right away. There's no hesitation. We go to work right away. And we're doing stuff right away. And if you're throwing up, it makes it a little bit more difficult to keep working while you're throwing up. So about 85% have some kind of a fluish, kind of a motion sickness. They don't know whether they're going to just have queasiness in their stomach or whether they're going to have a full-blown knockout, drag out, fill up the whole flight deck with throw up kind of an episode. The mission specialists can take medication on the ground. So we've learned over the years that there's certain kinds of cocktails of medication that the mission specialists can take that help us out with the space adaptation syndrome, which is NASA's fancy name for motion sickness. We call it SAS, space adaptation syndrome. Everybody's last meal is usually a very light last meal. The rookie pilots are generally the ones that are watched the most and teased the most, because as a rookie pilot, you don't know what your symptoms are going to be. You've never been in space. The doctors haven't figured out if you're a runner, if you're a weightlifter, if you're a pilot, if you're a scuba diver, what helps you either have or not have motion sickness. So all the doctors ever say is that we're all different. So which means you don't know what your body's going to react and how it's going to react. So I was teased a lot prior to my first flight, and what I decided to do on my last meal, most people will eat toast or cereal, something pretty light on their last meal. So we all sit together and have our last Earth meal together before we go fly. And I had decided I'd have double cheeseburger and fries. If I was up here, I'd have had a cheesesteak and fries, but I was down there, so I just had a double cheeseburger. And they all stared at me and wondered why I was doing what I was doing. And I just told them if I was going to throw up, I was going to do it like a Marine, and it was going to be something they could really talk about. And we gauged them. It's kind of the way we do things. So I was going to tell them that the top line of throwing up is called a 4-streamer. So it's just so thick, it'd fill up 4 ribbon streams of stuff coming out of your mouth. So I said, I'm going to do a 4-streamer. If I'm going to get sick, it'll be a 4-streamer. So that was my joke back on them. So as soon as the cameras got off of us, I had every pocket of my flight suit had a throw-up bag in it, an emesis bag in it. And Turned out that my personal symptoms had nothing to do with stomach awareness or stomach queasiness, so my stomach could care less about being in space. I would get these significant migraines like my head was going to pop off my shoulders with the fluid shifts that we have. So we have a lot of physiological changes that happen to us, and that's kind of what this slide is all about. We grow a couple of inches up in space. Our cardiovascular system changes pretty dramatically in space. A lot of hormone changes when we're up in space, not that we change sexes or anything, but it just puts out different elements. Our immune system changes quite a bit. Capillary systems, this is actually my second flight, and on my second flight they were doing a lot of stress testing on me as part of the medical experiment program they were running on me. So I was actually probably in better shape than I'd ever been in my life because I was running a lot, because I was running treadmill stress tests on a very regular basis, all hooked up. When I flew, the day before I went and launched on that flight, I probably went out and ran 5 or 6 miles at a pretty casual pace, day before liftoff. I went out and flew in space, exercised every day for 2 hours when I was up in space, came back home. About 3 days after I got back, I tried to go out for a run, and I couldn't make a half a mile. And what happened was all the capillaries in my large muscle groups just went away. They just weren't needed up in space, so they just went away. And it took a long time, months, to build those capillaries back up so I could feed the large muscle masses like my legs and not cramp all up. So a lot of physiological stuff. Some of it's pretty cool. Your legs get really skinny. Your hips get really skinny. If you got a spare tire, that goes away. Your chest gets bigger. Your shoulders get bigger. All the lines in your face go away. And you grow 2 inches. I mean, it's kind of a neat thing to do, except you can't keep it there when you come back. So a lot of medical experimentation, a lot of learning about ourselves and our bodies and what happens when we're up in space. We can work up in space in any orientation, on the ceiling, on the floor, on the walls. It doesn't really matter. When you think about some of the long-term space flight travel, there's a lot of stuff that has to change. We can go up in space for periods of time. We get a lot of calcium loss in our bones. We get a lot of additional radiation. So even though you see stuff on the news about some of the radiation hazards over in Japan, I can guarantee up in space it's well beyond anything that they're doing and getting over in Japan. So it's a very relative thing. And what NASA will do is they will study us the rest of our lives. So once a year, they'll pay my way to go back to Houston, Texas to go get a series of flight physicals and get the full-blown astronaut flight physicals so they can study us as we age and see if there's any long-term effects. And the only deal on that is, you know, they want to autopsy us when we die so they can check everything out and see if there's anything in there. We do a lot of physics experiments up in space. A lot of the physics experiments have to do with our food and our drink. Some people say it's playing with your food, but it's really a physics experiment. So if you take out a sphere and you let some liquid go inside the zero gravity environment, this is what you get. You can play with it, you can blow on it, it'll go from one end of the cabin to the other with a very light breath. Eventually when you're done playing with it and your physics experiment is over, somebody's got to kind of suck it up because you don't want to get in anybody's, you don't want anybody ingesting it, not on purpose, and you don't want it to get in any electronics equipment. So various kinds of food. Again, if you think about trying to go out and explore space, we can do this for a couple weeks. We got people that have done this for a year. We have to keep bringing them food as we do this, but the whole technology of food development, on one of my flights we grew bean sprouts but without any soil. So we figured out some kind of a compound that we could grow green sprouts in. It just kind of looked like a milky, thick substance, but we actually grew green sprouts. So if we're going to go to Mars and we're going to go to that next star that's 400 light years away and try to do it a whole lot quicker than 70,000 years, we got to be able to feed ourselves because we're not going to get much in the way of resupply. So there's a whole lot of jars of peanut butter I'd have to take up to last me for a lifetime of doing an exploration. Or even going to Mars and back is at least a 13, 15-month trip. So it'd be a long time to stay away. We don't go around without wearing shirts a lot, even though some of my slides seem to have us all shirtless. I didn't do that on purpose. We actually do usually wear clothes when we're up there. But I will tell you there's nothing sacred between us. We're all a small environment, 7 of us usually, sometimes 5, sometimes 8. There's nothing sacred. You can't do anything on a space flight that everybody doesn't know about. So some of the people that have asked us about having sex in space, You know, NASA would make you practice it 1,000 times before you went. There had to be a procedure that went along with it, just like there's a procedure I'll tell you about a little later on about going to the bathroom. And you'd have to practice it, and everybody in the world could watch. So it's not going to happen. Different kinds of food. Again, from a future spaceflight world, we've got dehydrated food now, but you have to figure out how you're going to feed us. If we're going to go away for years, and we're going to take the Star Trek Enterprise voyage of 5 years to go boldly where no one's gone before, you got to feed us. We either got to be able to grow our own food, or you got to figure out how to package it all in a pill, so we take 1 pill a day, and that gives us all our nutrition for the day. This is scrambled eggs. So you get a tortilla. We take up tortillas because we don't take up bread. Bread's too crumby, so we take up tortillas. So everything we do, we have Velcroed all over the place. So all the blue dots there are Velcro. And you take a tortilla, you clip it to a little alligator clip, you stick it on the wall, you slap on your dehydrated eggs, you slap on some ketchup or some taco sauce, and then you've got yourself a burrito breakfast. That's a cheeseburger that I made myself. Behind me to my side in that package, that's spaghetti and meatballs. So it's dehydrated, we rehydrate it with water. All our food is usually a very sticky substance, so it'll stick to the spoon so it doesn't float around inside the cabin unless you want it to. And then we take up a variety of other things that will go up there with us in space, like apples, bananas. But we also develop a lot of special talents when we're up in space. I mean, we can juggle 5 apples without any problem when we're up in space. I mean, we're just as talented. You ought to see me do a pommel horse when I'm up in space. And we do take up some commercial items. We're not allowed to talk about them. It's like it's a state secret that I can't tell you what they are, but I can tell you that they're candy-coated, chocolate-covered peanuts. But we're not allowed to say the brand name because Congress says we're not allowed to commercialize anything. So this shirt that I have on has got about 5 million miles on it, and it's a Land's End shirt, which I wouldn't be allowed to tell you if I was still active in the program. And we get a shirt for every day we're up in space. So I've got about 30 shirts, even though most of them I've given away to my family members. But they all have been worn, at least have a few million miles on them, got worn at least one day. If we could commercialize some of this stuff, that'd be different. You'll see astronauts wear at least 2 watches, just as a sidebar. One watch is called mission elapsed time. That's when the solids light off, that's time 0. So everything after that is mission elapsed. So we have pretty rigorous schedules, 16-hour day schedules. We get an 8-hour rest period. So the 16-hour day schedules at 3 days, 20 minutes, 3 days, 2 hours, 20 minutes. You're supposed to be doing this experiment. Here's what you're supposed to be doing. Here's your schedule. So we put one watch on mission elapsed time. The other watch we put on Earth time, Houston, Florida. We go around the Earth once every 90 minutes. So every 45 minutes you see a sunrise or a sunset. So we get kind of confused of what time it is down on Earth, whether the kids are getting up or whether the kids are going to bed. This is one of the greatest engineering marvels of all time. We were talking about it a little bit earlier today, but it took a lot. We call these head engineers. So if you don't know what toilets are called in the Navy, they're called heads. So if you're captain of the head, that means you're captain of the toilet cleanup if you're in the Navy. But a pretty amazing piece of hardware. What I tell the young folks is that you just can't be in a hurry. I mean, everything pretty much functions the way it does on Earth, but you can't be in too much hurry. Going back on practicing, when we practice this on Earth, there's a set of procedures you go through. And when we go into our little simulator on Earth, there's the little seat that you sit on. And to the left and right of that seat are these bars that are actually bars that you pull up and you put over your thighs to kind of help hold you down. Because that seat is designed for the 95th percentile anthropometric butt. And if you're not in that 95th percentile, you got to make sure you get a good seal. And it's not an easy thing to do. So, and the engineers couldn't design it for everybody. So they designed it for 95% of us. And you put your feet in the stirrups that are down on the bottom. That's if you're sitting down. You got to turn on some knobs and machines. Ground control, mission control will know that you've turned on the waste containment system. And if it's on too long, they'll call up, Columbia, Houston, is everything okay? We see the WCS is still running. Everybody listens to your radio call, so you can't call down and say, yeah, I'm on section D of the paper, so I'm not done yet. Liquid waste goes in that tube you see sticking out with a funnel. Another sidebar, it used to be that in the early days of Shuttle, everybody would get their own customized size cup for the guys. And then finally some engineer figured out that some of the guys were asking for sizes that were too large. So they were having, issues up in space with floating urine and stuff. So some engineers said, well, if I just make it a cone, one size fits all kind of a thing. And women have another special contraption that's a whole lot different than that one. And that was another engineering marvel, just to make sure, because you got to have these impellers and these pumps running, because you got to create a Bernoulli's principle flow so everything will go into the waste tanks that you want it to go into and not float around inside the cabin. There's hours worth of stories to talk about on that, but I won't. If you float up to something in space and you want to turn the knob, your body's going to turn, the knob's not going to turn because you don't have any torque on you. So the way we get torque is we have these foot loops all over the place. We stick our feet in those, and that gives us some leverage so we can actually turn the knob or turn the handle of whatever we got to turn. Again, but going back thinking about longer space flight travel, we're not going to be able to adapt to a zero-gravity environment for a really long period of time. We can do it up to a year, probably. We've done it so far. But there's a lot of physiological effects that happen to us without having gravity on board. There may come a day, as we explore this universe, just not that much different than some of the early settlers, where you actually have a generation change along your exploration. So some of the people that left Philadelphia on the wagon trains, by the time they got out to California, they had a generation change on board because it could take them a long time to get there, as well as some of the ships out at sea. So we got to be able, there'll be a time and place that we'll take families on board and we'll create families as we're going flying in space, or somebody will be smart to figure out how to put us all to sleep for 1,000 years or something if we're going to go to a far star, if we're not flying at some speed that's faster than the speed of light. So there's a lot of technology that's all going to happen. And if we don't do it, somebody else will do it, but it's all going to happen. So we've got to create that artificial gravity environment to help ourselves just physiologically, because you got to take care of who we are, and we're not going to change and adapt, even though your bodies adapt pretty significantly when you're up there. The sleep environment, we do dual shift or we do single shift kind of operation. Single shift means everybody goes to bed at the same time, gets up at the same time. In that place you go, sleep anywhere you feel like sleeping. And again, you sleep in any orientation you want to sleep in. It's all very comfortable. In the first day or two, if you want to feel pressure on your body like you do here on Earth, they have Velcro. Again, the engineers are just bright, bright people, because you say, hey, listen, I'm used to feeling a little bit of pressure on my hips and on my chest. Okay, so they make a strap that you can Velcro yourself down. I'd like a pillow. Well, your head's going to float. Yeah, but I still want a pillow. So you get a pillow, and then you have a Velcro strap like this guy out here on the right, and you can Velcro your forehead into the pillow. So you just put the strap across your forehead, push it into the pillow, and now you get the feeling of a pillow, and it makes you feel nice. And you put your arms out, they just float in front of you. If you're on a double shift operation, there's always somebody working, so we actually put boxes that we go sleep in the boxes. We call them coffins, but you just go to your coffin. And you go inside, you close the door, it's completely pitch black. There's a little bit of air current in there to make sure you don't suffocate. And you go to sleep, you just kind of float around in there, free floating. When you do wake up, it'll take you a little while to find the door to get out of it, so you can't really be claustrophobic at all. And it'll take you a little while, but again, once you're used to floating, it's very comfortable. We don't snore up in space, so there's no issues with that kind of stuff, because obviously snoring has something to do with gravity, so nobody snores up in space. People do have a lot of gas up in space, so that's just another issue that we worry about that I could take a 2-hour story about, but I won't. Sleeping in space, again, for the short-term duration stuff, close to Earth, that's not a problem for us. But we start thinking about this long duration stuff, there's going to be some technologies that have to be developed that allow us to go have long sleep periods or get ourselves back in gravity a little bit. Once you get used to sleeping in space in zero gravity, no pressure points on your body, it's really, really, really very comfortable. You could easily sleep 2 or 3 hours a night and feel very rested. Of course, you got to readapt when you come home, so it makes it a little bit more challenging when you come home. This is just a picture of the shuttle rendezvousing on the space station. This is over the southeast area, a little bit of Tennessee there, a little bit of Kentucky, coming down towards Georgia. We carry a lot of different payloads for space station. As we were building the space station, that's not a current picture of the space station, but it's a picture of about 2 years ago on the space station. It is a gigantic laboratory, and it's a great laboratory. I personally think that some of the cures that we're going to find for some diseases here on Earth are going to be found up in space. A good example for me is we did a lot of studying on protein crystal growth. There's some theory that protein crystals are the things that we can use to attach to cancer cells. They'll surround the cancer cell and not allow a cancer cell to grow. But we can make protein crystals or crystals up in space extremely more pure and larger by a long stretch than anything you can make here on Earth. And they're not bothered by gravity at all. So we can make pure three-dimensional kind of crystals up in space. You can mix up in space alloys, any other kind of minerals to make different kinds of alloys up in space. You don't have to mix your salad dressing up in space. You shake it one time, you never have to shake it again because it'll never separate. So same thing with kind of the metals and alloys that you could probably make up there you can't make down Earth. So there will be some things in the future of technology that we can use this kind of capability. And this will be a great laboratory. I had to testify once about the space station program and had a congressman ask about, well, what are you going to discover? What are you going to find? What are you going to invent when you're up in space station program? We're going to fund your space station. And for a split second, I felt like saying, I don't know. I have no idea. If I knew, why would we have to go? So I don't know. But then you come up with some other esoteric answer to say, well, new discoveries, medicine. We have no idea what we're going to find up there. We never did. I mean, Columbus really didn't have any idea what he was going to find when he made his voyage. He talked it through and he got the politics of it right. He had to go all around Europe to get somebody to finally fund him. But once he got somebody to fund him, he created. On the Space Shuttle program, the NASA program, the space exploration programs, return on investment that people have calculated, that kind of stuff, I think it's at least 7 to 1. So every dollar you put in a space shuttle program or in a space program, you're going to get $7 back of technology development. Department of Defense and NASA are they're the 2 leading developers of new technologies by far. The subsidies aren't developing any new technologies. Building railroads isn't going to really develop a new technology. So your engineers and your scientists are the ones that are going to develop new technologies. So you'll hear a lot of us astronauts bitch and moan a little bit about cutting 30,000 engineers and scientists off the NASA payroll for the 1/10 of a penny of a tax dollar. Again, space station's got a lot of stuff. We go around the Earth every 90 minutes, like I said. There's always this glow of the atmosphere when you look at the Earth. My first flight, maybe my first flight and a half, I was fascinated by looking down at the Earth. The 2 things you don't know about when you first go fly in space, you just don't know how your body's going to react when you get there. On your subsequent flights, your body will be the same or better, but it will always react. You don't know how it's going to be on your first flight, no matter what you've done previously. So that's the first thing you learn. The second thing you really learn up in space, that no matter how many pictures you can see, will never do it justice of what the view really looks like. I mean, it's a very unique environment, and cameras and digital photography just isn't going to hack it. So when you go look at the stars and the constellations, and I know there's an astronomy group in here, so you can't ask me any astronomy questions. Ask that to John Grunsfeld tomorrow, who's a real astronomer. I had a hard time finding some of the constellations that I knew when I was on Earth because it just gets obliterated with stars when you get outside the atmosphere. It's kind of hard to piece all that stuff together. But it's fascinating to look at it and realize how big and vast the galaxy really is. Those of you that would call this the northern lights, you would be wrong. These are the southern lights, so Aurora Centralis, but they're beautiful from up in space. This is a great, usually warm place without hurricanes and tornadoes most of the time. We get a lot of schooling and other things when you're in the astronaut program, so geology, astronomy for those that aren't astronomers, astrophysics, plate tectonics, we learn a lot about that kind of stuff. Erosion patterns, we learn a lot of things, oceanography, that we wouldn't normally learn in our lifetime, which is kind of a fun thing about being there. This is the delta off of New Orleans, Mississippi Delta. It looks beautiful from up in space. It's about 600 miles wide, just a hurricane. Turns out it's Hurricane Andrew. You're pretty isolated when you're up in space, and the people that you talk to when you're up in space is Mission Control, which is Houston, Texas, and the person you talk to is generally another astronaut. So the capsule communicator, Capcom we call them, astronauts talk to astronauts, the engineers kind of filter through the astronaut. And that way we get very used to, we know everybody personally, as well as if you're talking to another astronaut that's gone through the same kind of training you've been through, sometimes there's a way you say something or an inflection in your voice that gives you a clue of whether this is a good deal coming or a bad deal coming, kind of a thing. But this was taken from a space station crew, kind of seeing this from space, and there's a little bit of a zoom lens, just, hey, what's going on? So this is 9/11, as seen from the space station and taken from the space station. So you're up there, you're isolated, you just don't know what's going on, and you call home and they tell you. Kind of an interesting picture, and you don't see a lot of the borders drawn out, and I couldn't tell you exactly where some of the beginning and ending of some of the countries are out there, but this is that world of the Middle East, which has been in turmoil since the beginning of time, by the way. It's not like it's a new thing. So they've been that way forever. Hopefully they won't be that way forever, but it's been a place of turmoil for a long, long time. Moonrise, a little bit of the moon glow over Central America. Again, sunrise and sunset. So we'll see a sunrise, sunset every 45 minutes, 90-minute orbit of the Earth. So dark half the time, light half the time, plus or minus. That's the top of some thunderstorms, which are about 50,000 feet. Sunrises and sunsets happen really fast. They all happen in probably less than 10 seconds. But going back on the photography and the view again, we like to count colors as a hobby of the bands of color you can see in a rainbow or a sunrise or a sunset. On orbit, we can routinely count into the 20s, so 22, 23, different little bands of color. Find yourself the sweetest place on Earth to look at a rainbow or look at a sunrise or sunset, and you won't get above 10. So it's just the way the atmosphere diffracts and refracts. Another picture of that sunset. We wear the pressure suits. Kennedy Space Center is in the middle of the screen on the right-hand side, that little strip of land. It looks really small from orbit. I didn't talk much about the kinds of things you see in orbit that are really impressive with your naked eye. This is obviously with the lens, but with your naked eye, if you look really hard, you can see the pyramids, and if you look really hard and know where to look, you can see the Great Wall of China. So the man-made stuff, you know, one of the easiest man-made things to see from space is Atlanta Hartsfield Airport. Big runways, big piece of concrete, dark background. So you can see that pretty readily from space. If you know where you're looking, you can see this shuttle landing strip from space. The stuff that's really powerful to see from space are really the natural things, or the God-made things that are out there in space. The Himalayas is just the Tibetan Plateau. Those are things that just will boggle your mind to look at those things for the first time from space. That Nile Delta is a fascinating thing to see from space. The tongue of the Bahamas, where the water is just, it's a unique color of blue than it is any other place on the planet. So about an hour before landing, Mission Control will call up and they'll give the commander a whole bunch of numbers, 6 sets of numbers. Each number is probably 10 to 12 numbers long. You write them all down, you plug them into the computer. Somewhere west side of Australia, you push a button, an hour later you land at the Kennedy Space Center. I mean, how they do that, I don't know. But they call the numbers up, you plug them in, you push a button, and you come back, and an hour later you land at the Kennedy Space Center, or 52 minutes later you land at Edwards, California. So you pick. About 8-minute difference between West Coast and East Coast when you're coming home. It's the world's worst glider. Our bodies are trying to readapt to gravity. It's hard to lift your arms. It's hard to move your head. Your Your balance system is way off when you're coming back from a space flight. And again, that commandment, you can't look bad on CNN, so you just got to suck it up and make sure you land right and don't mess it up, and land on centerline, put the chute out, and look happy when you get out. Space station program, again, that's something we've talked about. We've been to the moon, but we haven't learned how to colonize the moon. We haven't learned how to mine precious minerals from the moon. They're all there, and someday we'll have the technology to be able to do that. One of these days there'll be a university on the moon, Moon University or something we can go to and learn a lot of things up there that we can't learn down here on Earth. And all that really keeps us from doing all of this is obviously the political will. But the technologies are all available, and we'll get greater and greater technologies, or somebody else will above us. And this is just Mars, which we'd like to go back to. Somebody about your age, maybe just a tad younger, but someone about your age can be the first one to walk on Mars, depending on the politics. We know we can get there and back in about 13 months if we land on one of the moons of Mars. If we get all the way to the planet and hang around for a couple months, might be a 2-year trip. So a lot of those technologies I was talking about have to happen within that 2-year trip. And again, we got to learn a lot about ourselves. There's just a lot of technology out there that's going to be pretty fascinating. You know, one day they'll be able to take our organs and grow new organs for us, and that might help us for these long-term space flights that we have to go. Shape-shifting different metals and objects that you can program to be a chair or a bed or whatever you want to program it into. But there's a combination of human and robotic partnership. So robots are great, and they get to go out there, and they don't have the limitations that we have out there. But you don't get to ever see the full picture, really, until you get the human out there. I mean, the human's got the logic and the intelligence to scope the bigger picture. So we've got a couple rovers on Mars. We think we're learning everything there's to learn about Mars. So you can look back in time. We're looking back. This picture's only about, this picture's only about 8 billion years old. So we're looking at the birth of a lot of stars. So those that theorize about the Big Bang, Hubble Space Telescope can take us back in time, because at the speed of light, we can look at stars being formed 10 to 12 billion years ago. So we can look back at the beginning of time, per se, with some of the value that we've learned out of the Hubble Space Telescope. We've looked at other galaxies. We know they're out there. We know that they've got billions of stars in those galaxies, or hundreds of billions of stars in those galaxies, and probably a couple billion or more Earth-like kinds of planets. This is a Hubble Space Telescope of, actually there's tens of thousands of galaxies in this picture. This is a very small segment of the sky. So going back on what Carl Sagan said about there's more stars in the universe than the individual grains of sand on this planet is actually right. I don't believe that there's life that's come out here and abducts people, does experiments, drops them back off on their farms. So we haven't had that kind of encounters. In one of my space flights, there's people that say that they know that I've had contact with aliens. And I brought one home on one of my space flights. And that's what National Enquirer said. And there's a TV special that was out there that said I've actually had correspondence with them, and I was trying to code a correspondence with Mission Control. On my last flight, we had this tethered satellite. Benjamin Franklin outer space, ball on a string, 12 miles long, looking at creating an electrical circle up in space with the Earth's magnetic field. Complex experiment, fascinating experiment, a lot of orbital mechanics, as well as how you use the radiation field, electromagnetic radiation, a lot of that in there. Well, the scientists put a factor of safety of about 20 on it. The engineers put a factor of safety of about 20 on it with the scientists' concurrence. Turned out this diameter string we had was smaller than a telephone wire, had a copper cord in the middle of it to create this current. So the scientists and the engineers that are designing this thing, you know, I was the commander of that flight, so my concern was all this electrical, I was going to be part of this electrical circuit, and not being a scientist, I wasn't sure what that meant for me personally. So I still wanted to have children when I came home and still have a family. So I was concerned about things they weren't concerned about. I was concerned about that. They were concerned, well, we're just going to have all this electrical flow going around and don't worry about it. Well, it turns out that we arced through the wire, broke the wire, 12 miles of string just kind of twanging out there in space. I was up, moved the ship away from it to make sure it didn't wrap around us. And so I guess I was the only commander that's ever really lost a satellite up in space. So I come back to the "you are here" and kind of just trying to wrap it up with this and say that, you know, we're just at the very beginning of this thing. And the talent that's in this room here is what's going to make it fascinating. And if we don't do it as this country, somebody else will, because it's going to happen. A lot of people talk about, well, we explore because we're made that way. Well, we are. And we're actually a nation of overachievers. I mean, if you think about it, we've outperformed all along in our history, which is why we're here, which is why we have the kind of economic power that we have here. So we're here. It's all at the very beginning, and it's an exciting place to go. And some technology out there is going to keep some of us from aging so rapidly. So some of us might actually be able to make trips when we're 100 years old up in space. With that, that's pretty much what I wanted to show you all. I guess, do I have time for any questions? Okay. That's my presentation. Anybody, any questions other than the astronomy group? No, go ahead.
What is your opinion on the portrayal of spaceflight versus the actual, like, being in space? Like, for example, do you think it's exaggerated or do you think it's quite accurate?
It's hard to portray something that you can't put everybody in that same experience. So, in other words, if you go out to Disney World, you can ride Mission Space. If you go out to Kennedy Space Center Visitor Center, you can ride Mission Space. And you get, even for us, if we train, we get simulations. We get thousands of hours in simulators. All of that trying to portray what it's going to be like when we get there. But it isn't. It's never like that when we get there. For me to land a space shuttle, I have 4 separate trainers down here on the Earth. So I have a simulator that's got a visual system that I learned how to land the vehicle in. Then I've got an airplane that's what we call variable stability airplane. So that airplane, we set it up that I move a hand control after the instructor pilot puts us in a simulation mode. I move the hand control, runs through the computers. Computer says, oh, this is what you just did with the hand control, so the space shuttle would react like this. And it makes the airplane react like the space shuttle is going to act. So we call it variable control stability airplane. I fly the T-38s around, which is just these little hot rod little airplanes, but that's just to get me used to the closed environment and an environment that I can work in a 3-dimensional environment, a real 3-dimensional environment where I'm feeling G's and I'm upside down and I can make 0 G. And I fly in another airplane called a KC-135, which is an old 707 airplane. And that teaches me how to land on the runway and maneuver this vehicle on the runway and maintain the stability of directional control that I need to maintain while I'm in the vehicle. So, and there's another one out there called the KC-135. So it's really kind of the 5th one that doesn't help me land the airplane, but tries to teach me about zero gravity. We call it the vomit comet because it just does these parabolas. And it gives you 30 to 40 seconds of 0 G on each parabola. So it's like a big roller coaster. But the 4 airplanes that I have to train in 4 airplanes to try to simulate what the space shuttle is going to be. You know, on that given day, I come to land the space shuttle. It's all going to be over in about 2 minutes. So if everything's working right, and George, we call it George the autopilot, it's all working well, and there's no problems, then I won't take over manually till about 60,000 feet, which will be about 3 minutes to touchdown or so. And then I'll fly the rest of the way. Well, I'll give my pilot about 15 seconds, and I'll take it away from him. And then I'll fly the rest of the way back around, and I'll do the landing. But there's no room for mistakes. There's no second chance, and it's the world's worst glider. You know, you're a refrigerator falling out of the sky, and you're trying to hold a 20-degree glide slope at 300 knots, and you start your flare at 2,000 feet, drop your gear at 300 feet. But and you have to land within 5 knots of a target speed based upon your weight, or you blow the landing gear. So it's all very precise, but we take 4 simulators to try to teach us how to do the one event. And we have to put all that, as humans, we can put all that together and do it when it's time to go do it. So trying to simulate or portray it without being in the real environment is really challenging. You know, virtual reality helps. There's a lot of new virtual reality stuff that's out there. We've gone from 3D virtual reality now into 4D, you know, where you bring in some of the senses into the 3D environment. That helps a little bit, but again, you've got to put yourself in the environment. For the soldiers and the Marines that are out there that I was a part of, we simulate being in combat and doing things in combat and reacting in combat. But there's no simulation other than a drill instructor screaming in your ear. There's no real simulation of bullets flying and, you know, sometimes body parts flying and the smell and everything of being in that environment. And it's so the closer we can get those environments, the easier it'll be for us to train and the less opportunity for mistake. But it's pretty hard. Another portrayal. So, you know, I went to Top Gun when I was in the Marine Corps, but it was nothing like the movie. It was nothing the way the movie portrayed it to be. And Kelly McGillis wasn't there. And I did meet Tom Cruise once, but he wasn't very impressive, to tell you the truth. And I couldn't understand why he got paid so much money to pretend to do something that I did. So it kind of boggled my mind, but that's the way of the world. Anything else? Yes, sir. No, been there, done that, kind of a thing. Most astronauts, in the astronaut world, as long as you can pass all the physical tests, and as long as you have a desire to keep flying, you can stay. But I knew the shuttle program was going to come to an end, and I kind of went back to what I said earlier. You know, maybe I have a short attention span because it's kind of a sad thing, but it's a human thing. I remember coming home on my last flight, and I remember as we were getting ready to do our deorbit burn, looking down at the Earth, one of the most magnificent sights in the world. It is, really. And I looked down and I said, okay, well, I'm not coming back. Been here. I've seen it now. So it was almost like a little bit of a boredom stepped in, like a short attention span kind of thing, which is very human nature. And so I felt it, and I knew I wasn't coming back. Plus, the administrator of NASA told me I was going into management anyhow, so I knew I wasn't going to fly again. And then I got this real inkling to go out into the business world because that's something that was really strange to me, so I wanted to try that and see how that worked. So I tried that in the big businesses, and then I got this itch to try being an entrepreneur. And I don't know whether it's a success or not. I guess I'll have to tell you that in some future date, but I'm working it pretty hard. And again, life is simpler when I just wore a flight suit. Just showed up, jumped in my jet, went flying around. Fun stuff. My sister Candy has a question, so it's got to be loaded. Yes?
Some of us want to hear about your turkey buzzard incident.
My turkey buzzard incident. Okay. So one of the things that NASA does when you interview, there's two kinds of astronauts. There's mission specialists and there's pilots. So the pilots are guys like me that all come out of the military, all have to be test pilots. So they select about 4% of the normal pilots that are in the military, and they send them to test pilot school or accept them into test pilot school. It's kind of a voluntary thing, and teach them how to be test pilots. So yeah, you know how to fly an airplane now. We need to show you how an airplane flies, kind of a thing. So all the pilots are test pilots. So all those pilots come out of the military. The other brand that's out there, which is probably about 65%, 70% of the astronaut corps, are the mission specialists. The mission specialists are your engineers, your scientists, your medical doctors. We have a veterinarian on board. So they're the smart folks, the astrophysicists, the astronomers. They're the folks that you really need for the science of what we're doing up in space. You know, the pilots, we learn science, and we learn how to do some science, and we learn how to do some engineering. Some of us have engineering degrees, but we forgot. So we get refreshed on all that stuff. But we're not the pure scientist. So you bring those people up because of their expertise. So they're the smart ones. So the pilots and the commanders, we're there to be in charge or act like we're in charge, but to make sure everybody's safe and to bring us all home and to take us out. So the interview process takes about a week. It's a week-long interview process. NASA will select about 120 people to interview for every given class they want to have. They'll announce a class. If you're in the military, you apply to your military branch, and then each military branch selects their group of people to send to NASA. Civilians apply directly to NASA. So my year group, there's about 15,000 applications, I think, that were qualified, listed as qualified. They interview 120, so they picked the 120 to interview. The Marine Corps picked like 21 Marines that year out of about 600 applications in the Marine Corps to send to NASA. And then they selected 15 of my year group. So during that interview week, and I'm getting to the answer, during the interview week, most of it is physical. Most of it is every medical test known to humankind for them to do on us. You know, there's a famous doctor who's called Dr. Hind. He'll do your procto exam and put the tube up you, but he's got a very appropriate name for what he does. It's his expertise. We were talking about that earlier today, appropriate names. They'll lock you inside a ball, like a giant beach ball, and hook you all up and then just leave you alone and see if you get claustrophobic. You know, see what you do. If you're 5 foot, 5'1", you can fall asleep and be comfortable inside that ball. But if you're much bigger than that, it's really uncomfortable. And they do other weird things to test you, ultrasound your organs. They do a lot of different stuff. So, but most of the physical stuff, for most of us that have been in the military, especially pilots, that's not a big deal. There's a couple social events that you go to, and that's a big deal for some of us because you actually have to go socialize with strangers. Some of us aren't used to doing that. And they give you some free time, and they expect you to walk around and introduce yourself to other astronauts that are inside the astronaut office. We're all on the same floor, the same building. They expect you to go in there and introduce yourself to people and talk to them and ask them questions, which another thing is uncomfortable for a lot of us to do. But they expect you to do that. And then the other thing is you have a series of psychiatric exams or evaluations. Some are really silly. We talked about some of them earlier today. I call them written exams, even though they say they're not exams, they're not tests, they're just questions. So would you rather throw up in a crowded bus or hit your thumb with a hammer? Your answer starts to identify your psychiatric profile. Would you rather be smart or beautiful? Would you rather be intelligent or rich? I mean, just the kinds of questions are, you say, why are you even asking me these silly questions? And you can't say neither. You have to answer the question. And then you get 2 4-hour interviews with psychiatrists or psychologists. I had one of each. And in that interview process, they go over your profile and they ask you the same question 10 different times in 10 different ways to see if you're lying to them, because they're pretty sure they're smarter than you are, and they can trick you into not answering what the right answer should be. For pilots, what the pilots have to do, you don't get in the highly qualified stack to be looked at if you haven't had some event that scared you, if you're a pilot. You have to have a life and death event. You have to have what they would call a high stress situation, or they're not going to want you. So if you've been a pilot and your life's just been perfect and you never had emergencies, you never had anything go wrong, then they're going to be bored with you because they want to know how you do when everything is going against you. So the pilots especially go through these high stress kinds of testing scenarios, evaluations. So one of mine, I guess, was flying a low level in an F4, 500 knots, probably about 300 feet, practicing coming in under radar, enemy radar. And right before it hit, I saw a turkey buzzard. So I guess I was encroaching on his territory. And he hit the airplane. And at that speed, even though it's a soft little bird, it's like hitting a cannonball. For that split second of time, it's a cannonball that hits that windscreen. Came in the windscreen, beat me up, dislocated my shoulder, crushed my voice box, blood and guts all over the place, busted up the ejection seat, put everything in a pretty bad state. And then the psychiatrists just kind of drill in. Well, what'd you think? What'd you do? I did what I was trained to do. I climbed, I slowed down, I tried to get control of things. Thought I lost my eye, figured out I didn't lose my eye, thought I was going to bleed to death, didn't bleed to death. You kind of go over all that stuff. I decided to go back to Beaufort because if I didn't go back to Beaufort where I was stationed, then I'd go into an Air Force base. I went to the Air Force base. They're going to take me to the hospital. They're going to do all this urine analysis. They're going to do all these testing on me, and it'll be a pain. I'd rather just go back to the Marines, and they won't be as rigid. They'll let me go home. Plus, I'll be late for dinner. So all this stuff goes through your head, and in initial instant you're saying, well, this is just a bad dream. I'm just dreaming this. And that lasts for, I don't know, things like it lasts for, you feel like it lasts for seconds, but it probably lasts for a split second. And then the pain sets in, so it's not a dream. So that was my turkey buzzard experience. But I eventually got everything under control. I had a very experienced guy in the back seat, so he didn't eject both of us out of the airplane. Otherwise, I wouldn't have made it because my ejection seat wouldn't have worked. I had a broken parachute container, so I got parachute flapping in the breeze along the fuselage, knowing that if that parachute inflated, it would rip me in half. So I hope it doesn't inflate. And then the process of trying to get your way back home. Can't see the runway, can't see out the windscreens. It hurts. Lots of blood all over the place. And I'm pretty squeamish. I'm a sympathy puker, so if somebody next to me throws up, I usually throw up. I see a dead animal on the side of the road and sniff it, I'll probably throw up. But for some reason here, just like when you have kids and you're cleaning up throw up and poop and all the other stuff you clean up with children, you know, it puts you in a different world and you don't think that anymore. You just do. So I just did and came back and landed, and that was the turkey buzzard experience. And I've had a few other scary situations, but that one probably lasted the longest. Yeah, I was 24. Just a young pup. But that's just part of the experience of getting to where you go. And we've got a lot of people out there today that do all that kind of stuff on a daily basis and just put their mind in the place where they got to be and make it all work. And they're out there, you know, doing the kinds of things that I mostly trained for. They're out there doing the kind of stuff and keeping it all together. And I mean, pilots are generally an unemotional breed because you can have a big fire engine blow up, and you know, maybe we're just slow analog thinkers, but either way, we don't generally get too disrupted with emotional outburst. Even though you can't help it in being in a space shuttle, when you finally get the main engine cut off, you finally want to look out the window and go, oh, cool, this is just so great. But you can't do that. You got to keep the calm demeanor going. Anything else? Yes, sir?
Well, with the problems that NASA is getting funding and stuff, do you think the future of space exploration in this country is with private companies? And if so, is that a good thing?
The politics of NASA, unfortunately, I think are pretty sad. The space shuttle itself, as a piece of hardware, could probably fly another 10 or 15 years. It was really designed to fly 100 times in space, and it's only flown about 30. Each one of them are all going to retire around 30 flights. So it's got the capability to fly quite a bit longer. The commercial enterprise stuff really has to happen. I mean, it's that kind of a evolution that ought to occur, just like every other transportation system we ever had. I mean, really somebody, it's right for the government to take the risk to develop the technology, to get something going. And then some smart innovator, entrepreneur, somebody will figure out how to make it into something that makes money. And they did that with airplanes. You know, the government built the airplanes, and then somebody figured out, well, let's use this for transporting people around and make some money. They've kind of gone too far nowadays, but that's what the innovators and the entrepreneurs finally figured out how to do. It'll eventually happen in space. There's a gentleman named Bigelow. Bigelow is the man that created, it was either Motel 6 or one of those budget hotel, I think, chain. So he's a billionaire. So he wants to make inflatable structures in space, which you can have, and make hotels. So for a couple $1 million, you can go spend a week in a hotel on orbit and have at it. You know, have a good time. You'll get a window to look out. You know, bring your wife or significant other or somebody along and have a good time. Take a honeymoon. It'll eventually happen. It takes a lot of money right now. For $25 million, the Russians will take you up to the space station for a week. So the privatization should eventually occur. It's not ready yet for prime time because they can't get it to the general populace just because of the money. Some of these new ones that are coming up that want to be private companies, it's a good attempt. It's a good start. The problem with it is that they've decided that they can't make the business case. So what they're going to do is they've come back and asked the government for funding, complete funding. So that if you're subsidized by the government, you're not really a commercial enterprise. And that's what's happening with them. And then, by the way, they're early in and they're just learning about rocket flight. And they've also are asking the government to indemnify them if they make any mistakes and kill anybody. So that's kind of the way it's starting out. But the space shuttle program going away and us not going back to the moon and Mars, I think is a big mistake. Us not having a way to get astronauts to the space station and making the Russians or having the Russians do it. The price of the Russians went up about 300% of what they're charging us to take astronauts up to the space station. So they've learned capitalism well. But for us to give up a system is just kind of sad. John Grunsfeld will probably tell you the same thing tomorrow, maybe more emotionally. Anything else? Yes, sir.
How much of an issue is
Space junk? It's an issue, but for the most part, everything bigger than your fist they'll track, and it's all in a very predictable orbit, so they can kind of move us around and keep us away from it. We do worry about little things, even like paint flecks that can put a pothole in our window. So we do worry about some kind of stuff. The probabilities are still infinitely high, 1 in 4 or 5 billion to get hit by one of these small specks. But it's there. And it's not as big of a problem now as it used to be, now that some things have deorbited. And hopefully in the future it will just get better. But it can be a problem if there's not guidelines. I tease sometimes lawyer groups because I said eventually the lawyers are going to get into space travel. I mean, as much as we'll try to keep it from happening, eventually it's going to happen, and there's going to be a lot of regulation that goes along with being in space and where you can deposit your junk and those kinds of things. We're pretty good. The U.S. is great about it. We don't leave any trash out per se and bring a lot of our trash home. Russians just throw stuff out there, but they're getting better. And now we got China, and now we've got India, and now we've got Iran and other countries that all want to get out there and do things, so we've got to be careful about how we do it. Well, I think I've used up a lot of your time, so I just want to tell you all thank you very much, and thanks for letting me out.